We are electric from the moment of conception. When the sperm enters the egg, it leads to a surge of calcium, and we actually get a huge flux of calcium outside the egg, and that causes the release of zinc from the egg. I'm sorry, I want to say that again. We get a surge of calcium in the egg, which causes the release of zinc out of the egg. And as the zinc shoots out, it binds to small molecules, which actually fluorescence and create light. And so this is an actual recording of that phenomenon. And so that is caused by the calcium flux and the release of zinc. What also happens with that calcium flux is it creates an expansion and contraction within the cell. So the cell is actually pulsing. It's actually moving. And I don't think we'll get into it today, but I'm happy to talk to other medical professionals, or if you are interested, about how these calcium surges are responsible for creating wave patterns in the body, such as the Traub-Herring wave that osteopaths work with, and that we sense with our hands as part of our therapeutic work. But this is, again, generated by ions. So we basically covered this. The movement in and out of the cells by the ions causes a pumping motion within the cells themselves. And the pattern becomes reflected in the developing cells. So this causes a spiraling of blood and tissue as these cells develop right from the start. We are starting to spiral. So think in your head of what an embryo looks like and how it folds up into two curved ends. I'll show you that in a moment. And then as the embryo progresses to a fetus and gets bigger, it unfolds. And we have this curling, uncurling. And again, this is all influenced by various forces, including the electron. Now, again, how does one cell become 40 trillion cells? And I really wanted to share, I'm very excited to present this work that's being done at Tufts. And this is work by Danny S. Adams, Laura Vandenberg, both PhDs. And what you're looking at is basically embryonic stem cells of a tadpole. And there's two little tadpoles here. Each circle is an individual little tadpole embryo. And what they've done is they've dyed the embryo with, the dye is reactive to electricity. So when electricity goes through the dye, which is being applied to the tadpole, it releases light. So when you see light on these embryos, when I run this video in a moment, what you're seeing is electricity. And then what is amazing is the actual physical features that are outlined by the electricity emerge after the fact. So the electricity is actually laying down a precise blueprint, imprint of where and how the face will actually form. So let's listen here.
Just cell divisions, lots of activity, front end of the spinal cord. There's the brain, mouth, pharyngeal arches, eye, nose, ear.
Can we see that again? Is that okay? So
just cell divisions, lots of activity, front end of the spinal cord.
So that's the spinal cord. That's the brain, my cursor.
Mouth, pharyngeal arches.
That's the eyes,
nose,
mouth,
ear.
And so you saw that light up first because electricity is preceding the cell. And this is what they're now believing keeps happening through life. So this is part of what allows us to continually regenerate. And I love this video. And this is from Howard Hughes Medical Institute. came out in 2018. And this is real time recording of stem cells in the embryo forming into a mouse embryo. And the bright luminescence here is the brain and the central spinal nervous system. And you can see the whole embryo, and it is starts as a ball, and these electrical forces going through specific axes of organization actually dictate how the embryo will move, that it starts to fold in on itself. And there's other mechanical forces involved in that too, and how structure actually forms in the embryo. And this is part of this new field of science.